Hello and welcome back to this tutorial series. In this episode I'm going to add the full text search, and therefore I'm going to use ElasticSearch version 8. And in version 8 the setup became a bit more complicated because Elastic turns on encryption by default. And what that means for the setup you will see in a second. So first I'm going to add the Elastic application. Then I'm also going to add Kibana because I want to have a front end for Elastic. And this part is new. We also need some setup for ElasticSearch. And as you can see on the right hand side on the minimap, this is quite a lot of code. But I mostly copied it just over from the documentation, which I linked here at the top. And I also modified the file permission a bit so that my Quarkus application can use the certificate that this setup will create. And you could also notice that there's a lot of environment variables used in this setup. Again, this is straight from the documentation. And to use them, we have to create an .env file. And again, this is from the documentation. Only thing you have to modify is the Kibana and the Elastic password, which I used change me here. So let's bring that up. And this will create the certificate, which will pop up on the left in a second. So here it is. And this certificate we need to use in our application. Otherwise, the application cannot talk to ElasticSearch. As I said, this is new in version 8. If you use version 7, you will not need that. Let's add ElasticSearch. This is the Quarkus dependency for Elastic. It's the low-level client. Reload the dependencies, and then we are good to configure it here. First thing we need is the username, which is Elastic by default. The password will just be change me from the environment file. And we also have to define the protocol, which is in this case HTTPS, because as I said, ElasticSearch version 8 will use encryption by default. And to actually now use this, we have to configure it in the code a bit. So I'm going to create a new package named Elastic. And here I'm going to create a context configurator. Just like this. And because this is quite a bit of code, I already prepared this. And as you can see, the most important part is just to provide the path where the certificate is, and the rest again is straightly copied from the documentation, which I linked here in the comments. So we just have to tell the application where's the certificate and then trust that one by loading it into the trust store. And with that out of the way, we can actually start to configure our index. So I want to have a book index config here. And this will define how our index for the book search looks like. And this will be app scoped because we need to inject the REST client here. Make sure that you use the ElasticSearch REST client because there are also some others. And on every start, we have to make sure if the index configuration is already present. And if it's present, we just want to return and do nothing here. And checking if this is present as a head request, which we do on the book index. And here we're gonna just see if it's present. So this will return an HTTP 200 if it's there. As before, I will add the exception to the signature. In a real application, you might want to use a try catch, but here I keep it simple. Next thing is we need the config, and this will be a JSON. To make it more visible what's happening here, I'm going to create a scratch file. And The book index will basically consist of two parts. The upper part is the settings with a tokenizer and an analyzer, and the lower part is the mappings, where we will apply the tokenizer and the analyzer. What they mean in detail I will explain at the end of this video. So the tokenizer we're going to use is an edge n-gram. Again, I will show you what that means in a moment. And I'm going to use two different analyzers. One is just for storing the data in the setting, and the other one is for searching. So with this, we can actually apply the analyzer and the tokenizer onto our fields for the search. So here I will have three fields: title, author, and a combination of both. And I'm gonna apply on them all the same mapping. Let's format that one properly. And you can see all the fields are of type text. The analyzer will be the autocomplete I just defined here. And the search analyzer will be what I'm defining here. So let's copy that over and paste it in here. And we're gonna build a request. This is a put request. Again, on the book index. Gonna apply the JSON, which is our configuration, and use the REST client to perform the request. All right, so this is basically all the configuration we need, and now we can create the actual service logic. So I'm going to create a book search service. You could also call that a repository. And again, this one is app scoped, and it has to be transactional because we want to use a repository here. And again, I use the REST client from ElasticSearch. I need an object mapper to transform a Java entity into a JSON string. And we're gonna use the author repository. And what I need here is actually I will need to find the author for a given book. So I'm going to create a join query for a book, just like this. And with that, we can find the author by the book, like this. And this will return an optional, so if it's not found, I will just throw, because that should never happen. Next, I want to transform the author and the book into the structure I just defined for the ElasticSearch. So I'm going to create kind of a view which takes an author object and a book object and brings it into the right format. And for that, I'm going to use a record. For creating a record, you need Java 17. And what I want here are string representation of the author, of the book title, and of a combination of both. I create another constructor. And for a combination of both, just like that. And let's create a new request. This time it will be a HTTP post on the book index. And here we want to create a doc. So call the doc endpoint, and I will use the ISBN number as an ID. You don't have to use that. You can also just create an automatic ID via ElasticSearch, but I think it's nice to reuse an already existing unique identifier like the ISBN. And again, we have to set the JSON entity, and for that I'm going to use the object mapper and transform our book view into this. And then just use the REST client, perform the request that we just created like that. And this time I will actually use a try catch because I don't want to handle it in the call side. I want to handle possible errors on this method, and also move this down because this can also throw an IO exception. And now the only part missing is that we call our book search service for every book change event. So I have to modify the book change listener, make this app scoped, and inject here an object mapper again. This time we have to transform into the other direction. We want to map from a JSON to an entity or to an object, and inject our book search service that we just created. And then we can use here the object mapper to read JSON that we got from Debezium, and we'll transform it into a book event. And again, I'm gonna create a record here. And this will give me a book. Let's add the exception to the already existing catch clause and use the book search service, add to index. Oh, here I of course need a variable, and with the book event we can actually get the book. So let's start the whole application up. And have a look at Kibana. First, I want to check if the mapping was applied successfully, and this looks very good. And also want to see if the book instances that were catched here by Debezium or were created by Debezium are really inserted into our book index. So I'm gonna make a search with this query, and as you can see, this query does not perfectly match the title, but because I turned on fuzziness search, I expect that it still returns something. And that worked very nicely. As you can see, it finds one of the books, which is matching this query more or less. As I said, it's fuzzy search. And what is really nice, you can see in the highlights which terms were actually matched. So it matches on the tower. Let's dive a bit more into the detail what this mapping actually does and why I think this is a nice improvement for the search and how this search as you type works. So if we go back to the JSON definition, you see we have here the edge engram, and what that means you can see by throwing something at the book entity with the analyze endpoint. And here I'm gonna add the text Sane Müller. And what you see here, it turns them into little parts of the first 2 letters, the first 3 letters, the first 4 letters, and so on. So this is actually what the edge engram does. So then ElasticSearch can easily match these little parts while you're typing. And the other one is the analyzer. You can see, of course, here we have in lowercase. So the input is transformed to lowercase letters, which is nice for searching. And the ASCII folding basically removes all this little extra accents and Sonderzeichen like in Müller and turns them into ASCII chars, so all the letters that you would expect in the English alphabet. And with that, we have a very nice way to find stuff while the user is typing. He's not writing it correctly and we still get a result. And as you saw here, we have also a way to highlight which part of the string was matched by the user input. So that's it for this tutorial. I hope you enjoyed it and see you soon.